Number 14. Alright, now we just have multiplication with a bunch of k's. So 14 is two rational, I don't even know what to call them. Expressions, yes. Two rational expressions. So we have k squared plus 12k plus 32. We have to factor. What can we factor that into? 8 k plus 8 and k plus 4. And then the one dividing it, k squared plus 13k plus 40. What can we factor that into? 5 times 8 will make 40, and 5 plus 8 is 13. So we've got k plus 8 and k plus 5 times k plus 5. Then the next term we have k squared plus 5k, and we can factor a k out of that. And beneath that we have k squared plus 6k plus 8, and that we can factor into k plus 4 times k plus 2. Right, so let's do that. Okay, once they're all factored out, we can cross cancel. So we've got a k plus 5 here, k plus 5 here, k plus 4, k plus 4, k, I like doing this, k plus 8, k plus 8. So that leaves us with k divided by k plus 2. Okay, number 15. We're more than halfway through this thing. We've got the square root of 2x plus 1 equals 13. It's a radical equation. So the thing we do with this is we try to get the radical on one side and everything else on the other side, and then we square both sides. So let's do that. We've got so we'll add a negative 1 to both sides. That'll give us a square root of 2x equaling 12. Okay, if we square both sides, we get 2x equals 144. And then we divide by 2, x equals 72. Woohoo! Number 16. So now we have complex numbers. We're going to multiply a binomial that includes an imaginary number, 6i, and another binomial that includes the imaginary number, 9i. But we'll deal with those i's, which represent the square root of negative 1, as a variable, because it's just easier that way. And we're going to multiply these two just like we would any binomial. We'll multiply the 8 times both terms in the second binomial, and the negative 6i times both terms in the second binomial. So what we get are 8 times 5 is 40. 8 times 9i is 72i. Negative 6i times 5 is a negative 30i. Negative 6 times 9i is a negative 54i squared. Okay, so now we'll combine like terms. We'll combine these terms here first. And so we'll keep our 40 the way it was, and then we're going to have 72i minus 30i, or plus a negative 30i, which gives us 42i. And then we still have the negative 54i squared. So I squared, since it equals the square root of a negative 1, I squared would be the square root of negative 1 squared, right? I squared would be. And then so I squared equals negative 1. Okay, so we'll change this. We have 40 plus 42i minus 54 times the negative 1. So that gives us 40 plus 42i plus 54. Okay, so now we're going to add, we add the 40 and the 54 together, which gives us 84. So this equals 84 plus 42i. Nope. 594. My mistake. I keep mixing that up. I'm entitled to make mistakes. Okay, yeah, 40 plus 54 is 94. So we have 94 plus 42i. Number 17. Here we have another a couple complex numbers. One is dividing into the other. And the way you do these divisions is you use something called the conjugate. So conjugate works with another number just like the difference of two squares works. So you'll see it eliminates the middle term because one's positive, one's negative. I'll show you what a conjugate is. So the conjugate, because we want to clear the imaginary number from the denominator. So the conjugate for 8 minus 3i is 8 plus 3i. And then we'll leave the top as the same. No, excuse me. We're going to write the same thing on the top. I don't know why I said that. Okay, so 8 plus 3i. See, if we multiply 8 plus 3i or 8 plus 3i, we're multiplying by 1, so we're not causing any trouble here. Right? So, we'll do the top first. 3 times 8 is 24. And then 3 times 3i is 9. Oh, too close to the top. 9i. Then we have 4i times 8. That's 32i. And 4i times 3i will give us 12i squared. And you know what's going to happen to that. And I'm not going to get it. Not to do that again. Okay, there it's rewritten. So, but before I simplify that, I'm going to do the bottom too. So now watch what happens with this 8 minus 3i and the 8 plus 3i. So it's obviously the difference of two squares. So 8 times 8 is 64. And it's going to be minus what 3i squared is, which would be 9i squared. Okay, so but you see the 9i squared, I squared, as we saw before, is a negative 1. So we're not going to have any i's in the denominator, right? So let me copy this thing over down below. Okay, so we have 24, and we'll just keep that, 24, and then we have 9i plus 32i, which is 41i, and then we have 12i squared, but as we know, I squared is a negative 1, so it's a minus 12. And you can see we can simplify that even more. And down on the bottom we have 64 minus 9i squared, but that I squared is negative 1. So actually we have a plus 9. So okay, I'm going to simplify it to down over here. So I can add the 24 plus the negative 12, that gives me 12. And then plus 41i. Okay, and then the 9 plus the 64 gives me 73. And now, to make this even uglier, we have to have two terms. We have to have the real number term and the imaginary term. And the real number term comes first. So we'll divide the 73 into the 12 and the 73 into the 41i. Or we'll actually make fractions out of them, really. So we have 12 73rds plus 41 73rds I. There we have it. Number 18. 7x squared plus 8 equals 575. So we're supposed to solve this. Now, this looks like a quadratic. Well, it is, but notice it doesn't have the middle term, an x term. It just has the x squared and the constant. So we can solve it in a different way. So first things we have to do is get it the constant and the squared number on opposite sides. It's the squared variable. So first thing we'll do is we'll subtract or add a negative 8. So we have 7x squared equals 567. Okay. And then we're going to divide by 7. Divide by 7. And we get x squared equals 81. And take the square root of both sides, right? Take the square root of both sides and we get x equals 9 or negative 9. Number 19. X squared plus x plus 4 equals 0. Now this one, we're going to get imaginary roots out of, and you can tell that by the answers that are available. It's one way to tell them. Also, we're not going to be able to factor this, so we have to use the quadratic formula. Quadratic formula is negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, now a good way to do this is to write out what your a, b, and c are. So a equals 1. This is where a is. B, this is b. B also equals 1. And c equals 4. So we just plug these into this quadratic formula. So negative b, negative 1 plus or minus square root of b squared, which is 1 squared, which is just 1, minus 4 times a, which is 1, times c, which is 4. And that is over 2a, which is 1, so 2 times 1 is 2, so we'll just leave it like that. Then we'll simplify this. So we have negative 1 plus or minus square root of 1 minus 16 over 2. And now I've run out of room. Okay, so that gives us negative 1 plus or minus the square root of negative 15 over 2. But we can't just leave it like that, square root of negative 15. Because square root of negative 15, we're going to do this, maybe over here. Square root of negative 15 equals the square root of 15 times the square root of negative 1, which we call I, right? So we could write this as I square root 15. So this becomes negative 1 plus or minus I square root of 15 divided by 2. And that's the answer. Number 20. Now for this one you'll need a calculator for. It says, answer the question, you will need to use the formula 4.9 t squared plus VO or V0 t equals s. And you need to know that V0 is the initial velocity, the velocity something starts out at, and the s is the distance from the ground. Okay, so after you know that, if you know what numbers, well, 20 meters per second. A coin is tossed downward with an initial velocity of 20 meters per second. Okay, there's your initial velocity. See, it says it, initial velocity of 20 meters per second, at an altitude of 158 meters. So there's your S, your meters. So all you have to do is plug this in, but then of course you have to solve it. And you'll need your calculator for that, and we'll need the quadratic formula. So what we have here is we've got 4.9 t squared plus v0, which is 20 meters per second. So we'll just put 20, and that's times t, and that equals s, which is the height from the ground, 158. Okay, so now we've got to get the whole thing equaling 0 so we can use the quadratic formula, right? So we'll add a negative 158 to both sides, which gives us 4.9 t squared plus 20t minus 158 equals 0. Okay, so let's actually make a note of what our A is 4.9, our B is 20, our C equals a negative 158. Okay, and so we know what our quadratic formula is from the last one. And if not, you should write it a number of times and do a bunch of problems that involve the quadratic formula. You can go into your book and find, you know, the section that has the quadratic formula, do a bunch of problems, and you'll remember the quadratic formula after you've done about 5 problems. So, okay, so we're going to use the quadratic formula. So it's a negative b, which would be negative 20, plus or minus the square root of b squared, so it's 20 squared minus 4ac, so 4 times a, which is 4.9, and I ran out of room again. That is times, how am I going to do this? Maybe I can move it over. Okay. Times a negative 158, and that's over 2a, and remember a was 4.9. Now we'll just solve this on the calculator, and I think the easy way to do this is to start off, push the square root key, depending on how yours works, but I would do the square root key, and if it then opens up a parentheses inside the square root, then inside that you can put 20 squared minus parentheses 4 times a negative 4 times 4.9 times a negative 158. Okay, and then just solve that part first, and then do the plus or minus negative 20, and then divide by 2 times 4.9. So solve the square root of that calculation, and then you add it to a negative 20 rather than subtract it, because the number of seconds can't be negative seconds, so it has to be a positive number. And then you divide by 2, 2 times 4.9, and you'll get 3.993, I think. And that is very close to 4 seconds, right? So we'll round it to 4 seconds. And that's how long it takes. Okay, number 21. Now we have a composition problem. It says, given f of x and g of x, find the indicated composition. So it tells us what f of x is and tells us what g of x is. We have two functions. And it says find f circle g, or f composed of g. So f composed of g, that's the same thing as f of g of x. So it's like, so the function of g of x, which is this, is going to go inside the f of x. See, so we're going to put it inside that x squared. So we could say that this f circle g, or f composed of g, is this. It's this thing squared plus 3. And this thing is this. I'll stick that in there. 3x minus 5. Okay, so all we have to do is simplify this thing. So 3x minus 5 squared is 9x squared minus 30x plus 25 plus 3. Okay, and so then we combine the 25 and the 3 and we get 9x squared minus 30x plus 28, which is actually a pretty simple problem. It just sounds complicated, but it's not hard. Number 22 says determine whether the function is 1-to-1. If so, find a formula for the inverse. And you could graph this formula, but what helps is to recognize that it's a line. You notice that it's not x squared. The x is not in the numerator. It's not radical x. And if you wanted to divide this, I mean, you could think of this as g of x. We just call it y for now. Okay, so we'll call g of x y, and so y equals 4x plus 5 divided by 9, and so we'll divide the 9 and we'll get y equals 4/9 x plus 5/9. So if you look at that's a line. That you can see that the x doesn't have a power, or that the power is 1, and same with the y. The power is 1, so we don't even put them down because they're assumed. And you could even graph this if you wanted to. Keep in mind that if we graph this, it just has to pass the horizontal and vertical line test to be 1-to-1. The slope is 4/9. Actually, you could make up some points. You could graph this thing, and you'll see that. So we go up 4, 1, 2, 3, 4, somewhere up here, and then over 9. I don't know, way over to here. So it's like a straight line, like that. And a straight line is 1-to-1. The things that aren't 1-to-1 are like quadratic equations aren't 1-to-1. Because they don't pass the vertical, no, not the vertical, the horizontal line test. And I don't think you're going to see any of these other types of functions like the cube root function, x cubed. So I think you're going to see a line, and lines are 1-to-1. So automatically, and you actually think about it. Look at the 4 answers. The 4 answers we have available to us are 9x minus, the inverse function is 9x minus 5. They give us 3 answers that are inverse functions, and only 1 answer says not a 1-to-1 function. So chances are it's a 1-to-1 function because the author of this test wants you to find the inverse. See, so good chance it's going to be a 1-to-1 function. Unless you find that there's several questions like this, but I think there will only be one. So, okay, so let's solve this. How do we find the inverse? Since we've decided that it's a 1-to-1 function, how do we find the inverse of this thing? Well, first you start out by writing the function down. So we've got g of x equals 4x plus 5 divided by 9. Okay, so then we make y equals 4x plus 5 divided by 9. Now to get the inverse function, you switch the y and the x. So now we've got x equals 4y plus 5 divided by 9. Okay, so now we solve for y. We've got, I guess I'll write it up here. I guess I could do it, actually I could do one more thing. So we can multiply both sides by 9, so we get 9x equals 4y plus 5. Okay, and then we're going to add a negative 5, right? Because we want to get our y term alone. And that gives us 9x minus 5 equals 4y, which I'm going to write up here now. 9x minus 5 equals 4y. But we want to get y alone, right? So we'll divide by 4. Divide by 4. Okay, so then we have y equals 9x minus 5 divided by 4. These 4's cancel out. And that becomes our G inverse. G inverse equals what y equals, which is 9x minus 5 divided by 4. Number 23. This problem is the number of bacteria growing in an incubation culture increases with time according to B equals 4,400 times 3 to the x power, where x is time in days. So find the number of bacteria when x equals 0 and x equals 2. So this is really easy, except that, you have to know how to do the order of operations, and but you just plug in 0 for x and then 2 for x. So we have B equals 4,400 times 3 to the first one is 0 power, which 3 to the 0 power is 1, so it's just 4,400. That's the first one. The second one is B equals 4,400 times 3 to the second power. And by the order of operations, we do the 3 to the second power first. So it's 4,400 times 9. So we just have to calculate that. So we get 39,600 for the second one. So that's this answer. In this case, we can see the answer. It's 4,400 and 39,600. Okay, this next one is express as a single logarithm, and if possible, simplify. Number 24. So we have 1/2 the log base a of x plus 7 times the log base a of y minus 3 times the log of base a x. And this is a simple problem in that we know the rules for logarithms. So when they're added like that, we can turn it into one log and make it a multiplication. And when they're subtracted, we can make it a division, a quotient. Okay, so let's also we need the power rule. So we have 1/2 log base a of x is the same as, I'll have to do these power rules first. It's log base a square root of x, because that 1/2 becomes the exponent. And then we'll do the next one, which is that 7 log base a y becomes log base a y to the 7th power. And then the last one, minus 3 log base a x becomes minus log base a x to the 3rd power. Okay, so now the next step is to start combining them so we can end up with one logarithm. And this is actually helpful, you'll see, for a problem we're going to do in a little while. So the first two are added together, so we can combine them as one log base a of y to the 7th power times the square root of x. And then, of course, that's minus log base A, x to the third power. Now this one, now that we have two, now we're down to 2 logs, and we're going to combine these. When it's subtracted, you can make it the quotient. So this equals log base A y to the 7th power square root x divided by x to the 3rd power. Now it said to simplify these. Once we combine into a single logarithm, to simplify. So what we can combine are those x's. So I'm going to rewrite this. I think I'll change colors. Okay, so we have, I thought I was going to change colors. So we have log base A y to the 7th power, and I'm going to make it x to the 1/2 power. That's the same as the square root over x to the 3rd power. Now we can divide the x to the 3rd power into x to the 1/2 power by doing this. We'll make it log base A y to the 7th power times x to the 1/2 minus 3 power. Okay, but a 1/2 minus 3 is 2.5, right? Let me do that over here. I'll do it with the blue again. So 1/2 minus 3 equals a negative 2.5. And that mixed number can be changed into an improper fraction. 2 times 2 is 4 plus 1 is 5. So that becomes 5/2, right? So what we've got now is log base A y to the 7th power x to the negative 5/2. And you know, a negative power, actually we can turn it back into a positive power by putting it in the denominator, or making it as its reciprocal. So the final answer, you'll be glad to hear, is log base A y to the 7th divided by x to the 5/2 power. So number 25. So it says, where appropriate, include approximations to the nearest thousandth. If no solution exists, state this. We solve this. And so this is an exponential equation. So we're going to solve this exponential equation, if we can, by having the same base with 2 different exponents. I'll show you what I mean. Remember, we have this rule that if b to the x equals b to the y, then x equals y, right? So this is a case where we can use that principle. We can't always use it, but in this case we can. We have 3 to the 2x plus 1 power. And that equals 243. But 243 is what? It's 3 to the 5th power. See, so if that's 3 to the 5th power, then that means that the 2 exponents are equal, because they have both the bases are equal. They're exactly the same, right? So the exponents they must be equal. So 2x plus 1 equals 5. And of course that's simple to solve. We'll subtract 1 from both sides, and then we end up getting 2x equals 4. Divide by 2, divide by 2. X equals 2. Oh, here's the answer. Number 26, closing in on the end here. We have the log of x plus 4 minus the log of x minus 3, and they equal the log of 2. So we can figure this out. We'll just use our rules we did before. Notice we have 2 logs that are being subtracted from each other. There are a few ways to work this out, but we'll do it this way. So this is the same as, and this is log to the base 10, because there's no base written in there. So we can assume that it's a common log, or base 10. So this is, since it's x plus 4, log of x plus 4 minus log of x minus 3, then it equals log x plus 4 over x minus 3. And that equals a log of 2. Now, just like the exponent rule, if there's the log of two numbers, if there's a log of the same base of two numbers, they're equal. So here we have x plus 4, x minus 3 equals 2. So that's easily done, easily taken care of. So we multiply both sides by x minus 3, and we get x plus 4 equals 2 times x minus 3. X plus 4 equals 2x minus 6. And then we'll add a negative x to both sides. And we get 4 equals x minus 6. Add 6 to both sides. And we get x equals 10. And we can check this, and it works out. We don't end up with a negative log. So, and we could test it. We could go log 10 plus 4 divided by log, 10 plus 4 divided by 10 minus 3, right? Which is, and that's supposed to equal log of 2, right? So 10 plus 4 is 14, 10 minus 3 is 7. So we've got the log of 2 equals the log of 2. We needn't go any further. Okay, the last one, number 27. Log base 9 of x minus 5 plus the log base 9 of x minus 5 equals 1. Now I can see a few different ways of doing this. So, well, we'll do it the way we've been doing it though. So the log of to the same base of two logs added together equals, in this case, log base 9 of x minus 5 times x minus 5. And that equals 1. Right? So we could just call that log base 9 of x minus 5 squared equals 1. So this one, we'll just go back to what it means to be a logarithm. This means, this log of base 9 means that 9 to the 1 power equals x minus 5 squared. Okay, so that means that x minus 5 squared equals 9 to the 1 power. And of course, 9 to the 1 power is 9. So we can take the square root of x minus 5, the square root of the square of x minus 5, so we get x minus 5 equals 3. Add 5 to both sides, and we get x equals 8. Now you may be wondering why I didn't get x minus 5 equals plus or minus 3, which would give us two choices here. We would either get 8 or we would get 2 for the answer, because 5 minus 3 is 2. 5 plus 3 is 8. Well, if it's 2 and we put it into here, we would have the logarithm of a negative number, which we can't, because nothing to any power will give us a negative number. So that one's out. So this is the only answer. Okay, and thanks for playing. So here are the answers to all the questions we did. Hopefully my answers in the review match these. And we can relax and now sail off into the tropics if we want, and bid each other a fond aloha.